As I said, we came up with this name, Door Spotter. That's the name of our web application. And if we move forward, we want to tell you a little bit about why we did this project. So as 3 BI track emphasis students, we wanted to find something that was very data heavy, something that we could use the BI skills that we learned along with all the other skills in the classes and put together a really nice comprehensive project. And what we kept coming back to was off-campus housing. As students that have been here for several years, there's some resources out there for searching for housing and getting value when you're trying to find somewhere to live. But we always struggle to find a single source, somewhere that everyone felt comfortable, excited about. In fact, we kind of teamed up with a student advisory council who did a pretty extensive report on off-campus housing and the situation of finding it. And directly out of their report, I'll just read these 2 quotes. It says, students had to search through the internet for hours and then begin the tedious process of trying to contact landlords who are often difficult to reach. This is describing the current process, a little bit of the pain that students expressed that they were going through. The solution that the students suggested, and I don't know if you can read that in the back, so I'll read it out as well, said when asked what would aid them in the process, they overwhelmingly said a central database would be the most beneficial. And so through the course of this project, which has been extremely data heavy, we went out and collected data, and we'll go into a little bit more detail. We went out and collected all kinds of data and put it together in this web app, and we'll describe a little bit of the technologies we use before we actually show you what it looks like.
Awesome. So a lot of these technologies, maybe some of you will be familiar with. For us, a lot of us have had exposure to quite a few of these. However, for our group, it was a nice opportunity to dive deep and get to become intimate with some of these technologies. So on our front end, we used your basic HTML, CSS, JavaScript, and a number of jQuery plugins to make things look nice. However, the fun came in learning the back end. It was our first time using Python, and in particular the Django framework. In addition, we use some of these pandas libraries that Tyson will talk a little bit more about. They're Python libraries to help with some of our business intelligence and data analytics. We use the PostgreSQL database to store all of our data. It turned out to be really nice instead of like MySQL or SQL Server or something else. And then we were able to keep it all synced together on GitHub, which we have become very good friends with.
So throughout this process, we've all learned a lot of lessons, and it's all been, since it was a really comprehensive project, we all learned lessons in a lot of different areas. I was sort of the head of our data collection and cleaning, and so I learned that data is hard to get, and it's even harder to make it in the form that you want it. We got in contact with the Office of Off-Campus Housing, and they were really helpful and willing to lend us their data. But there was still a lot of work to be done to be able to put it in a database and also collect other nuggets that we wanted to include. And so that was just a big effort. Another lesson was that we detail planned the front end of our website before we did the back end, and that ended up helping but not being a huge benefit because we ended up changing the front end as we did the back end anyway. So it would have been nice to have a template, but we didn't need to detail it at the beginning. And then, as Wes mentioned, we learned new technologies of Python and Django, and there were a lot steeper of learning curves than we had expected, and so it took a lot of time, but it worked out.
So for my lessons learned, I'm a big proponent of paired programming. Some of you are probably the same way. Even this morning we had some issues, or earlier this week. It's so nice to have Heather or Tyson or one of our nice classmates out in the audience come look over our shoulder and say, hey, you forgot a comma, and then everything works. It's funny how that works out when you have thousands of lines of code. So anyway, paired programming, way of the future. I also believe strongly in making this modular. It worked out really well. As Heather was saying, she kind of took over the back end and the database, data cleansing. Tyson kind of took more of the analytics role, doing a lot of the BI technologies, and then I kind of took the web developer front end role. And it was nice because we were able to help each other as needed, but we each kind of specialized in a certain area, which helped us manage our time a lot better. As well as Tyson mentioned earlier, Sean Sutherland hopped on this project for a little bit for our web dev project, and he worked on some of the Google APIs, so it was really nice to be able to kind of hand him that without having to interface with some of our other code, so it worked out really well. And then last, it's nice to see the fruition of our education. We used, I think, skills and tools from every single class, from Dr. Dean's Business Intelligence to Systems Analysis with Dr. Anderson, Security, Dr. Vance. I mean, pick your favorite professor, and we used some Project Management with Ernie. We're grateful to see that all of our skills came to use, and the same here.
So some of my lessons learned, and I think all of us would say that these are all of our lessons that we learned, but specifically I was kind of in charge of the business intelligence aspects, the more machine learning algorithms. And it's a newer area out there. It's kind of a new frontier. There's not as much documentation. There's not as many helpful examples. I felt like in a lot of ways I was blazing a new trail, trying to get different libraries to work together and take our data from what Heather had produced in a really nice database form to then throw it through these machine learning algorithms and get extra value out of it. So that was a really fun, long, interesting process. The other thing is scope creep is very much a real problem when you have a very feature-heavy site with off-campus housing trying to design a site that we thought, oh, students could use this, and they could use this, and they could use this, and all of a sudden our list was 40, 50 items long, and at the beginning we went like this, scope got longer, and then it just kept getting shorter as we went back. But what we've delivered we're really happy and excited about, but definitely creeped out and creeped back and all over the place. And then along with what Heather mentioned, task estimates, when you're learning new technologies and dealing with new processes, it's a kind of hard learning curve. And so we'd say, yeah, that'll probably take me a day or two, and then 2 weeks later say, yeah, now I finally just got it to where I want it to be. So that was an interesting lesson learned. But going back to the machine learning a little bit, since our project is a BI project that has a web interface on top of it, I want to make that really clear, that we spent months going through the data, getting familiar with it, cleaning it. I mean, Heather could go on and on about all the wonderful things that she did in that area. But when it was finally ready and we had it in the form that we wanted, we used a lot of the principles out of Dr. Dean's class to then group it together in ways that made sense. So I'll just give you an example. When we collected all of it, there were really 4 different types of off-campus housing. There were condos, there were large complexes, there were small complexes, and there were houses. And all of these had unique and different features, and so what we did is we clustered those all together, condos, houses, large complexes, and within those larger things, we then clustered fall-winter prices and spring-summer prices and year-round prices together. And then within that, we even clustered private and shared rooms, because all of those variables made things so much different. We had to take it and organize it in such a way. But when we did that, our whole idea that we wanted to do with this was, how can we best predict what rent should be at a given complex? What are the variables that are out there that indicate to us what average rent should be? Here's an example. I know you can't read this at all. These different colors represent how correlated these different items are. Let me just give you one example. For average rent for a condo, fall, winter, private room, one of the most influential factors was how many bedrooms were in your specific unit. Another was bathrooms. Another was, do you have covered parking? What type of laundry do you have? Do they supply Wi-Fi? Is there assigned parking? All of these we found to be very influential variables, and that's what we put into our model to help predict price. And you're going to see how that comes out in a web interface. All of this data work, we're going to show you what you came to see, the nice presentation of it. So let Heather take that away.
Okay, so let's imagine an example. Say there's a guy named Ziggy. He's coming from somewhere international, Ghana, and he's trying to find a place to live. He wants to study business, and so he wants to have a short walk to the Tanner Building. He also doesn't know anyone, so he wants to have a roommate who can help him out, so he wants a shared room. So with those things in mind, there are a few questions we want to consider. The first being, where should I live, and how do I even start knowing where I should live? There are a lot of options. Well, there are a few different options of sites you can go to, but we wanted to make one that would be the solution. How do I know if I'm getting a good deal, or what is a good deal at BYU? housing options. So that's just another question to consider. And then other things like what my ward will be like, how will those factors affect my lifestyle while I'm at BYU?
So now we're going to hop into the really exciting part of our presentation and actually show you our site. Tyson is going to simulate the role of Ziggy, our nice football player, strapping young man. So let's get started. So this is kind of the bulk search site of our web application. So to start, if you want to simulate Tyson, Ziggy would probably want to choose, obviously, hey, I want to live with other dudes. I, as Heather said, probably want to live with in a shared type of room. Want to get to know somebody who's American, maybe show me around. I don't really care what type of complex type. I don't care too much about laundry or air conditioning, but I really want a pool because that sounds amazing. And then price range, I don't want to spend too much, so let's say, yeah, right around there sounds good. So we search, and you'll see a whole bunch of our nice little crosshairs logo for door spotter. And these each represent a different complex that meet or fall within the criteria range that Tyson just selected. So if you want to select one, see a nice little pop-up, and oh, the Riviera tells you where it is, tells you some nice little information. If you can't read this, you have the price, number of bedrooms, number of bathrooms, and then if you click on the name, it'll take you to our details page.
So, and this is really the meat of our project. This is where all the data analysis that we did really comes to a front interface. We worked really long on the data underlying this that you can see, and also on how it appears here. What we have is typical housing features that you'd come to expect. Things, I mean, obviously the name, some pictures about it. We've got a really nice price table over here that shows you what type, how many bedrooms, baths, if it's private, shared, the prices over here. And then underneath here we have some details. You can see our amenities, our air conditioning, laundry, utilities, such as. Really comprehensive, all-in-one view, all together, based upon the criteria that was selected. But now we want to get into the BI aspect of it. So I told you before that we spent a long time trying to determine how do we best predict price. How do we predict it within these different clusters? What do we do there? So here's what we came up with is if I come over here to men, and let's say he wants to be in one that has 3 bedrooms, I click on this $279 price, and right here we have this pop-up that shows here's your actual price, here's the $279 that the complex is advertised at. Based upon our variables and the analysis that we've run, we predict that the price should be at $285. So you're, in essence, getting $6 more worth of value for your buck. Not as drastic in this example, but in other places throughout this site, there's much more. You're getting a lot more, you're getting a lot less, but here's what you're paying, and just another data point for students. This is really nice and intuitive, we felt, and I'll have Heather explain what this is, because this also adds value to this, and show you a little bit more.
Yeah, so for the percentile, we grouped the housing options similar to how we had before, and we said that percentile means how many people are paying more for a similar housing option. So the Elms is a large complex, and we look at a price.
Riviera.
Oh, the Riviera, sorry. The Riviera is a large complex that we looked at a price for fall-winter, and so compared to those other options, about 50% of people are paying more and 50% are paying less. Other features, Ziggy wanted to know how far it was to the Tanner building, and from this we know it's a 9-minute walk, which is pretty quick. But say like 2 days a week he has an 8 a.m. religion class, it's 16 minutes away from the JSB, so we'll have to wake up a little earlier.
So
and then,
where are you doing your calculations? Did you pre-populate these?
Yeah.
Based on
it's a Google
Like
API.
that.
Cool. Great.
And then to find out more about the ward, we know that the stake that the Riv is in the Provo YSA 9th stake, and then we get a listing of wards that you could be in based on which apartment you live in. And if you want to find out more, see what time you have to meet, you can go to LDS.org, and then you know who your bishop is and that you have church at 10:40, so it's not too early but not too either. And then say you want to check for availability. Currently we're just purely informational. We don't do contract hosting. And so we can look to see if there's any listings listed on BYU's off-campus housing website. And since there's not right now, which is unfortunate, you can go to the landlord website and hit apply now or make a phone call and see if their availability is there. And even after all that, if you decide you don't really like the Riviera, you can look at other options that are similar to the Riv. And based on a survey that was done at the housing fair, price was the most influential thing that people considered when looking at housing. And so these are all large complexes also, but they're within a similar price range.
So within a similar price range, are there other characteristics or attributes that determine those clusters that fall down into selection of these?
That's all built into that. And I mean, this is just the view of, as we said, a lot of data underneath. There's a lot of things that we feel that can be improved upon a lot of features that we want to move into the future with. But overall, this has been a really rewarding project. We've learned a ton about data analysis and predicting value for a certain thing. We've learned about how to present it in an easy-to-consume way. We're really glad that it covered such a comprehensive list of all of our courses. Literally from the first class of the core all the way through now, we could pick a principle that we took from each class and applied here. And more than anything, we feel like this can make an impact for students going forward. That was one of the criteria that we had when we wanted to choose a capstone. Is we didn't want to just do something, turn it in, be done, and have a grade. We wanted to have something that could be impactful, something that could be built upon in the future. We think this fits the criteria of both of those things. And so this was our web app, and we're excited to show it to you. And that's it.
Very good. So tell me a little bit more about the processing behind it. How often would you need to recalculate the weights on your models, and how automated is that? Is it realistic to think you could pass this off to someone else to maintain, or how involved would you need to be?
So I'll speak for the specific BI area of it.
Yeah.
It's automated to the point where you could add a new complex. You could add a new listing if there wasn't one on here before, and it would run through all the algorithm stuff again, add it to the list, go through the variables, define it, save a value for it, and it would pop up. So it's it's there.
Nice.
Yeah, Dr. Anderson?
So that is a ton of data, and that is phenomenal. And do you have things, I'm sure the format was crazy. Do you have ways to automatically update, or is it just snapshot and then 4 months later you're going to take another snapshot?
Right now it's just a snapshot. So we've been talking about lots of different ways to sustain this, to make the data updated, but right now we're not sure what that is.
That's amazing.
Is it likely that this will be used in the transition?
I guess we could answer that. We like what we see. We just, last week, the team came to our office and showed us a little trailer of what they're proposing, which is basically just a map. This is the first time I've seen all this, and I am impressed. And I'm certainly glad I don't have to compete against this team. Yeah, there's going to be further discussions.
That's good.
That's good.
Sounds like a sell to me.
Data, the hard thing is it is variable and it changes based on what the landlords have. And so that's something that the interface would have to be updatable. Right now, most of what they did, what they've had, is from the data that I pulled from the listings that we have, which again changes on
Yeah.
a daily basis.
I think that, and I talked with the team about this, the only way to make that, there's only two ways to do it. One is to actually have the landlords themselves update their profile. That's obviously the most direct and easy way. And anything you put in the middle between them and the landlords and getting that done is just going to cause drag in the system. So, giving them a login and giving them rights to update their project data is the best way. The next way, which is not the best way, is the hard way, which is, periodically you have to go get the listings and do that. My thinking was, and it may be a little bit optimistic, my thinking was that this is a sales tool for the landlords, and so the onus, the impetus is there for them. They have built-in incentive to keep it up if it's out of date. And you could even put in some sort of a penalty clause that if they don't keep it updated, you guys just remove them from the site. So you could put, it's not very hard to put a little bit of teeth in it. Be reasonable, but say, guys, if you're not keeping this up, then we're going to go ahead and remove it. Let the students find you another way. And so there's a couple of things you could do that I think would help.
Oh, and along those lines, we do an annual contract with the planners. They have to sign it every year. And we are working with IT to try to automate that. If we could then tie into this, at least once a year it would be updated if they were required to do that when they were.
Do they hold their prices stable for that year? Is it like a contract, or do they move around?
Yeah. There may be some change, and if we could give them an option of going in later and saying, right now, our prices for 2013, 2014 are this, when they go to list for the 2014, 2015, or 2014, yeah, they can change that. If
Okay.
they have that option, that would be a good thing. So.
And just to, is that end to end or is that 20 minutes end?
That's end.
End to end? Okay. One
But that's
quick last thing that we wanted to show you, and that kind of follows along with what we're talking about. These are some of the things that we're wanting to eventually expand, in addition and most importantly to sustainability of the data. But we also sent out a survey and have collected hundreds of results. They just haven't been formatted and put into the site yet. But we want to do family and married housing because that's a big emphasis that people need. We want to put review systems in to a more qualitative review data point for people. We have ideas for breakdown, side-by-side comparisons, different views, best deals breakdown, and then as we talked about sustainability, anything you guys want to add? It's a laundry list of potential items, and so we're excited that we're the first iteration, but we're hoping that there'll be a second and a third and a fourth and so on to the point where this is a snowball rolling down the mountain. So,
Very good. Great job.
thank you.
All right, up next, I think we have Tim and Tim. Yeah, we'll lights on. Allow us to see you. So.
I know. Yeah.
You definitely, I mean,
It's the left side. On the left side. Things about
but I did fill out your survey. You know that.
Yeah, that's right. It's just beyond the stairs, but it's right there. Thanks for coming. Thanks for sharing the data so that you can try to solve that. I mean, I know
Like I said, man.
Oh, it's this, man.
That's right. Thank you, thank you.
Oh, the school program.
So,
Project.
I've narrowed it down to what the machine is.
wonderful. All right, we're going Again, I'll kind of try to give you a heads up in 20 minutes-ish, but you'll have 25 total.
Okay. Should we leave the light like this?
Yeah, if we could, that would be good. We can actually see which would be
Okay.
great.
So,
Take it away.
all right, just before the presentation starts, I want to thank our mentor, Dr. Vance, and then Dr. Dean and Dr. Mercivi and our family, friends, and that help us on the way. Without you guys' help, we won't be standing here presenting to you guys for this. And so let's just get started. So our project is about the enhanced password. So our journey starts with the idea of we think password itself is insecure. So is there any ways we can do to improve the security of the password? So we have a bunch of ideas in the beginning, such as we have the points on the picture, which is like Microsoft. What they did is you click certain points on a picture to determine if you're the right user. And then we're thinking about typing biometrics, which is the way you type determines who you are. And then click on a difference, more like we have two similar pictures. You click on a difference on the pictures, and then determine like who you are. But then after going through all this and the meeting with our mentor, quoting from Dr. Van, said, "Do one and go deep." So that's when we decided we should do and actually we chose typing biometrics. So we think it'll help us a lot in the process of learning it. So here comes our new scope, which is we think the contribution to the field, to the IS field, is we're gonna create a website which will demonstrate the whole typing pattern biometrics and then two-factor authentication. So the question comes, why don't we just make a functioning system? The answer is because someone already done it. We don't want to do someone already proved that it works. We don't have to prove it works. And what we're gonna do is we're gonna conduct a survey that uses the website and to compare the two methods. And then lastly, we're gonna write a conference-style paper with our findings and say which one is better and in what way. So coming to our topic is typing biometrics. Is people, we all type differently, even though we don't know it. And then this is actually quantifiable, like the time between which the keys, you press the key and then the time you press the next key, and the total time we just add them up. And then the timing group is the natural breaks during the typing, such as the password we use a lot, Batman. People naturally break on bat and man. So, but how can this really be measured?
So we first wanted to base off, sorry about my voice, I've been a little sick, statistic-based quantifying, which would include things like the means, averages, standard deviations, z-scores. But this actually turned out really bad, and here's an example why. With a standard deviation, it's a variation in the way you type. So if we measure the way someone types and it varies greatly, it'll be a bigger standard deviation. And we made proprietary percentage equations and group made other equations to decide the probability of the person being the right one. So going back to that standard deviation, since the variation was greater, it made it easier for the not real user to log in as the real user. So if you type not consistently, it'll be easier to log in as you. So it wasn't accurate. It was really bad. We would have I would register, and then I'd try to log in, and I think it was me 26%. Then Heather or someone else would go in, and she would be 90. And then Tim would be 70, and then I'd do it, and I'd be 100. It was just all over the place.
I thought you had success early on.
It was mediocre. It was like 50%. It was like hit and miss. So, well, it wasn't acceptable. So we had this idea. Who could know more about this than we do? Well, obviously, Dr. Dean. So we actually used some BI type intelligence things. So we learned we should use machine learning kind of like the other group, but this time we're going to use logistic regression. Logistic regression is categorical variables. True, false, yes, no, real user, not real user. And we use this instead of linear regression because linear regression is progressive. It just outputs a number like 22 or 30. It's not yes or no. So we went with that. And the sad part is we spent over 25 hours on our other algorithms that were mediocre at best. So I won't say we wasted 25 hours, but it was 25 hours that we couldn't get back. We learned a lot, but now we had to move on to a new system. But by now, we already started our website. So let's talk about the technology of our website real quick. So we use Visual Studio Professional 2013, and then we use ASP.NET MVC5 framework using NDD framework code first. What that means is you write the code for the database, and it creates the database for you. You don't create the database first and then make the code fit it. It's the other way around. We use SQL Server, CSS, HTML5, JavaScript, Bootstrap, jQuery, all kinds of technologies. Mainly they were used for capturing the way you type. It had to be done on the front end because of the latency and other issues. So we used jQuery and JavaScript to capture the time of your typing, and then we use that to pass it on to our back end that does some more analysis. Okay, so there was definitely issues and then some. Learning that many technologies, I have experience as a back-end programmer in C# for BYU Broadcasting. Tim has some experience with front-end, but neither of us had a lot of experience with those technologies and implementing them all together. So we had quite the learning curve. It would easily take 3 hours to try to figure out how to do something, and it still wouldn't work. And a good example is we have a cutoff of the probability. It has to be greater than whatever their cutoff to gain access. I wanted it to be a little slider. I spent 3 hours trying to make it slide and grab the number and post it to the model on the back end. I couldn't get it to work. So 3 hours, and I had nothing to show for it. But of course you guys are wondering, does our system actually work? Can we actually use logistic regression to tell if you're the right person or not? Well, we're going to find out. So actually need probably 2 volunteers, and someone's going to register on our website, and we'll see if they can log in, and then we'll have someone else try to log in as the other guy. So you will say what your password is. So this is the website we made. It's called thesecuredpassword.com.
I didn't know this password is. Not sure.
Well, I wouldn't be surprised if it's Batman. We use that as our test case, and I probably wrote that word like 1,000 times, just Batman, Batman, Batman. Okay, so the first thing you'll notice is, yes, you have to confirm your password 9 times. You're typing your password a total of 10 times. It does seem excessive, but you have to add the data, and we found about 10 true users was just about enough with the help of Dr. Dean that we could get really good results. So yeah, whoever wants to register, hopefully it works.
on the whiteboard and then
Write it on the whiteboard?
yeah, so the next person can try it.
There's probably a marker behind the screen.
So part of our website, we did implement 2-factor authentication, and it could be through email or text. We had both working. Last night we were having a few issues with the text, but basically the way it works is you can imagine you register, and when you log in you can say 2-factor, and when you try to log in it'll send you a text or an email with a verification code that you then have to put into the website.
What if they make a typo when from the
Yeah.
past?
Yeah, I'm a little worried I might have.
Unfortunately, if you mess up, it's going to erase all of it. So hopefully.
We had to pick an easier one.
And the reason was we had to capture their timing sequence right now. So we did set up that they mess up and they knew it, they could hit the backspace and it automatically erased just that one line and all the associated data, and they could rewrite it. But we did find a bug that if they highlight the entire password and start typing without hitting the backspace, it would cause some issues with strings and, lists being too long.
That's
So
a good feature though. If you could just pick out the ones that are different and then just highlight them and let it type over that.
That's good.
Is it my turn?
I mean, that's a solvable problem.
yeah.
So we saw Todd just registered and had his profile set up. Let's just leave the cutoff as default 75, and I don't know his phone number, so we're just gonna choose that as email notification, and we're gonna save it. And now,
Coda.
so Coda is gonna try to. He's a hacker, and he's for some way social engineering or somehow he found out what Todd's password is, and of course his email as well. So we're gonna try to log into this Todd Wilson. Yeah.
Okay.
That's his password.
Definitely.
Okay, so he wasn't able. Todd, why don't you try again? Try.
Oh!
Oh, he got it.
Man!
Yeah.
Probability 99.99%.
That's really accurate.
I'll try that again.
No, it's fine. There's obviously issues. I would say this is a pre-alpha. And one of the major issues is logistic regression creates an equation. The equation is going to have its coefficients that are plus and minus. So if you happen to wait longer on a plus coefficient and you wait sufficiently long, you'll be able to gain access.
I'm not following.
Yeah, so maybe I probably can't see this very well. So
You can just put it up if you want, Christian.
I actually don't know how.
Just press the up arrow on that white thing on the wall.
It's on the wall, huh?
Oh, well. So the logistic regression works as I'll have the output probability, but then you'll have the coefficients and the intercept. So you'll first have your y-intercept, and then your coefficients.
Yeah.
X1, X2, X3, X4. But then each of these will have their own sign variation. So it could be minus, plus, minus, minus.
Yeah.
If they wait long enough on that keystroke between those two characters, sufficiently long, that could offset the minus to give them a probability high enough to gain access.
Oh, I see. You're just saying.
Plus- Plus, the system works better if the password is actually your own password. If it's just a vocab, just word from dictionary, because we for those that word we all type similar in the sense of we all type Android first and stinks, and then we know because we know what word it is, so we know where to go to next. So that's why so if it's your own password. It's random enough, and the password, if the password is longer, then the system works better. So,
Wait, does that probability surprise you though? I mean, even though it's a logistic regression curve, probability really surprises me.
The reason is the class we use for that is what's it called, a chord something, and if the data set is not large enough, the data won't converge. So if the data won't converge, then the probability will be either 1 or 0, and that's it. So this is a feature we don't have just yet, but we're hoping. So in the beginning of user login for 10 times, and that's their initial data, and then afterwards we will capture users' sequential input, and then as our data set becomes larger and larger, the probability will be a lot more accurate than it is right now.
There's another way to solve this problem, and that is, right now, according to your equation, one long one can offset another short one. But you could actually do like a decision table where you could say, you could create a logistic regression for the distance between variable 2 and variable 3, or character 2 and 3. You could make that one decision. You could have a variety of those, and it would have to meet a certain amount of those to be able to pass as satisfying. Then what you're doing is you're breaking the overall problem into pieces and solving that, letting the logistic regression solve each one of those, and then you don't have a compensatory problem. You don't have really long in one being able to clobber, really short in 3 others or something like that. So that's we have that's a solvable problem too. Yeah.
All right, thanks.
Yeah. So our website is let me show you which part. Well, right here, this will show the type that you method you use to come in, like typing or email or text, and it'll say what IP address it came from, the start time and end time. Now, this came in handy for our survey, which we're going to talk about here in a minute. The purpose of the survey was to gather information of comparing two-factor authentication with typing authentication. And one of the things we want to know is, well, what's the time difference? Like, if you have to type in your password 10 times, maybe it's still faster than getting an email or text and putting in the code. So we use that for that.
But that's only on setup, right? I mean, the real comparison is every time I log in, which is a single instance of my password.
Yeah, so if Todd logs in again, it would be a new instance, a new row in the table. So, excuse me. So we also made a little management page. And this aggregates some of the data that we got from other users who logged into the system and tried our survey. So we can see for typing authentication, the high was, oh, it's off. Sorry. Oh, can't move.
Just move the browser.
Okay. The high was 18 attempts. On average, the time was, well, 1.2 seconds. And the average probability was 80, and I assume it's because there's a few zeros in there, like someone wasn't able to log in. For email authentication, the high attempts was 2. It took someone 2 times to try to put in the verification code. And this one actually took 282 seconds, so about 4 minutes. With this one, though, I actually looked into the data a little bit, and one user waited 40 minutes.
Yeah.
So there's one just really offsetting it. And text authentication took 1 try on average, and it was about 75 seconds. And average attempts being lower than 1 is weird. I was looking through the data, and it looks like some people attempted to log in, as in they put in their information, they said 2-factor authentication, but then they didn't get like an email or text is what I'm guessing. So their attempts were 0 because they never got a verification code.
And then just kind of FYI, having the standard deviations on these would be really helpful.
Okay.
Just so that you can take into account the amount of variance.
Mm-hmm. And then we show all the details. It's not scrolling for me of all the login attempts and all the information about it, which is quite a bit. So that is the website we created. There's a lot going on in the back end. From the front end, it doesn't look like much, but on the back end, there's a lot going on. You can believe us in that. So that is our website, and let's continue our presentation. And I think, yeah. So next steps.
With the website setup and working, and we set up and administrate our own survey. We had a survey about 19 or 20 questions to ask a user to set up their profile and try to log in with different ways. And then, here's the survey result we get. For the first, in general belief, we did have a question ask people how do they believe in password security. And then about 68% people said, which is majority of the people, said they care about it, but they're too lazy to do anything about it. Which means they want to do something to increase their password security, but it's just too much trouble for them. And then in general, in the end, about 60% of people believe that our way, the type authentication way, is more secure.
More secure than what?
Than the two-factor authentication. So on average, the score for the simplicity, how complex it is, it's about 5.6, with 10 being really simple, and 1 being complicated, and about 6 for the easiness, which is 10 being very easy. And then for the user, for all the survey participants, about 68% of them said they would use two-factor authentication, and then for the people who don't want to use it, about 75 people think they don't want to use it because it's too time-consuming. And some interesting comment we had is one person said, I used the two-factor authentication way to store all my mom and my dad's password, so I don't think it's safe enough. And then some people think because email and text is something you use every day, so it's easier to remember on the user end. So now comes to stats for the typing off. The simplicity and the easiness is about the same.
I'm sorry, can you go back? I misinterpreted what you were saying. Okay, I see. Thank you. Like the general beliefs, and then
Yes.
you went
And
into two
those two
factors.
factors.
Now we're on to your scope.
And then,
You have about 5 minutes.
okay, great. And about 60% people will say they will choose to, and then the people who don't will say the reason is because it's too time consuming. I assume it's because we ask the user to type in so many times when they set up the profile. And then we did ask people like how many times do you think they should type in the password in the beginning when they set up the profile, and about 40% said, which is about half the people say about 3 to 5 times. But according to our experiment and stuff, research, it's only 3 to 5 times is not enough.
So was the question, how many times would you be willing to type in your password to use this method, or was it a methodological question of how many times do you need to in order
It
to
was
get accurate
how many
results?
times do you think you should?
But again, kind of the methodological question, I don't know that they would know that, but
Right.
there may be a barrier to entry
The idea was
in
to
using
kind
the
of get a
technique.
feel for user experience to what you actually need. So we know most users think they should only type it 3 to 5 times.
That's
So-
for set up the profile, not when you log in.
Yeah, I got that. But so it was, how many times would you be willing to type in your password to use this method?
Mm-hmm.
Okay. Yeah, because those are two different things.
Right. It's how many times they think they should.
And yeah, the people, some interesting comments. Some people think typing pattern is so hard to remember, and then some people say TPA is like a fingerprint. No one types exactly like you, which is basically the idea of this project. So,
Great. So we had a lot of lessons learned. First is project management is more complicated than it seems. Especially, we're only a team of 2, but there are several times where we're kind of like, what do we do now? What should we work on? And plans and scope change a lot, especially in our project. This presentation is kind of a journey through our experience. We started with having all these ideas of authentications and ways we could do it, and then it changed. And then we started making our own algorithms, and then it changed. So you gotta expect the change. It's always going to happen, and scope always changes, whether more or less. And that goes into prioritizing tasks. Like I mentioned earlier, I could spend 3 hours working on something, and it didn't benefit me in the end. I had the experience of learning how to do it, but it didn't get implemented into the system. And also it goes into the value of an hour. It's pretty self-explanatory. Every hour actually matters. And technology is more complicated than it appears. I think Tim has some feelings on Team Foundation server. It was kind of hard to get set up and to understand that technology. We weren't sure if it was pushing stuff to our server or if it was just not easy to get that working properly. But we think the most important lesson we learned is purpose is key to your direction. If you don't know where you're going, you're never going to get there. So our future plans and our hopes. Well, we need to complete our paper on our findings still, which we'll do for Tuesday. And if we had the time, our hope would be to create a web service API that could implement this, so it could be a login service, kind of like you use for Facebook or Gmail on other sites. We could do something similar using this technology, and if we could ever get it to work that reliably, patent the idea and the technology. So this is our presentation on the enhanced password. So I guess the question now is, are there any questions?
All right, first, very good. Based on your experiment and your experience, your experiment, you simply had the individual use your system. Do you have any data or feel for? My guess is that Coda coming up and typing in that password was atypical. What percentage of non-users successfully can replicate the typing behavior of actual users? Do you have kind of a rough percentage?
We didn't focus on that too much because biometric typing measures have been done and published, so we wanted to focus more on just two-factor versus typing authentication. So we don't have any hard numbers, but through experiences, it's usually not very often. Example, last night, Tim typed in his password, kind of silly, but he was trying to type it different, and he kept logging in. It's like, well, I'm typing it different. This is weird. So the system still recognized it was him. Then I tried it, and I couldn't log in. I tried twice.
Mm-hmm.
So it seems pretty
to
accurate.
validate the approach, I think you need to have a very solid number that people feel good about. Certainly there's two layers, the password itself, and then the typing behavior, but you still got to feel good about that typing behavior.
Yeah. If I could redo it, what I would do is on the management on the website that I showed you, I showed that there's for a regular user when they log in, there's a log of when they logged in, but it's based on if they come in. Let me explain that better. So if you try to type in your password and you fail with the typing off, it counts as an attempt. And then if you try again and you fail, it counts as an attempt. So there's two. Then you do it a third time and you get in, there's 3 attempts. If I could go back and change it, I'd probably make each one an individual log in the database. That way we'd have all the information, like, well, this person tried to type this way, the probability was this, and we'd have more data and that could validate the logistic regression.
One of the reasons we couldn't do that is because it's a public database, so we had to hash out a password. So there's no way for us to know the other user's password to have some non-user to type in. But we did have a preliminary test that we've done, collect about 20 sets of data, and we test some of them with logistic regression, and it actually worked. And the result was, we compared the result with Dr. Ding, and the result was actually pretty good. That's why we felt it's good. It's
confident.
So that's one angle of the issue. The other angle is, as a legitimate user, how often am I going to be locked out? And I've noticed in my own typing behavior, anecdotally, that different states that I'm in mentally or emotionally may produce different behaviors. And so the flip side is how many times legitimate users use it at different times of the day. When I get to about 2 in the morning, I slow down, and so maybe that's a good thing. I can't get in to do any additional work if I'm too slow, right?
Yeah, it's an added security feature, actually.
That's a good point. It's a good point for, I think that, remember the I class we talked about true positives, false positives, and then we also had, false negatives. And so we don't know, and you just haven't, maybe you have, but I haven't seen the data yet that says how a classification matrix falls out. Are we usually failing because it's a false positive? That we think that this guy is the real thing, but he's not. Or are we usually failing because it's a false negative? It's the guy's tired and he's just not typing the right speed. It's interesting that should be done. That should be evaluated. I mean, your point's very good.
We definitely agree. It would be much better if we had like 20 or 40 sets of data for the true user. That would make it much more reliable. It'd have a greater variance in the ways they do type at different times. But with the time and everything we've done, we didn't have time to implement.
Yeah, and I think you've done a great job with the project, so don't interpret my comment wrong. To useful to make an impact, maybe even academically, you'll need to gather lots of data and kind of parcel out those questions.
Good. So I have a question, but I think Steve is first.
So did you try different kinds of keyboards, like maybe a soft keyboard
So
on
it's
an iPad?
interesting you asked that. Someone who took our survey last night used that iPad, and he was able to successfully register and log in with typing authentication.
But what about when he switches keyboards?
Probably not. Our original scope before we changed it was we had that in consideration, but what we were going to do is basically add a 2-factor authentication, so that way you could say I'm on a mobile device or something, and instead of it, basically just turn off the 2-factor or typing authentication and send a verification code instead. But once again, that our scope changed and we didn't focus on that feature as much.
And did you tell us what resolution you could get on the timing here? I mean, are web browsers somehow inserting processing to delaying the timing, or are you getting a pretty accurate representation of what the hardware is doing? down to the millisecond level?
It's milliseconds.
Have you verified that, no, I know your numbers are probably coming out in milliseconds. You verified the accuracies that maybe by comparison with what you get out of the operating system native device driver versus what the web browser.
Oh yeah. I did research that a little bit. My findings I can't remember too well, but I want to say that we found that the resolution and the accuracy wasn't quite as good running through a client side because it's using JavaScript to grab the date time at that instant they do a key up. So it's not as accurate as grabbing the date time that your computer or server would be running. But then you run into other issues where if you try to get off the server, there might be a latency between me in Utah or someone else in New York or wherever have you. There might be other network-related latency issues that could.
Well, definitely is good client side.
Yeah. So that's why we went with jQuery and JavaScript to do that.
Have you considered testing your model using simulations?
So
where you can have millions of data points or billions even,
mm-hmm.
and now we can see really what the breakdown is, true positives, false negatives, and so forth.
Yeah, we were kind of moving in that direction with Dr. Dean. We did do testing on 3 data sets. They're fairly small. They're about 20 rows in the database. And it did learning on 14, and it did testing on 4 or 5. And 2 of the tests were 100% accurate, and the other one was 80%. But we haven't done a full, larger scale. We haven't. We kind of ran out of time to keep pursuing what we could.
We also talked about random generation of data based on those 10 to produce, lots of samples that the model could be trained on. And
we actually went that route. We implemented that. We made it so once you get your 10 registered versions, the system would look at your high and your low and add a little bit of a buffer and randomly select more data to create spoofed versions of your own typing. But we didn't feel comfortable because it could be totally wrong. It could be kind of right. We didn't
as long
really
as your
have.
distribution is right,
Yeah.
you're probably okay.
Yeah.
Kind of bootstrapping the model.
Mm-hmm. But we did have to do that for the false users because logistic regression, you have to have the true users and the false users. So we did build an algorithm that would look at how many time betweens your typing, your password has, and then it would go and make up its own based on a time between keystrokes of 30 milliseconds to 300 milliseconds. And that's what we saw from most of the data is most people type within that range. So the system would go through, say your password's Batman, that means there's 5 time betweens between each character. So the system would go through it and spoof 5 time betweens and add it to the database. And we did that so that way every time you log in again, it's going to use the same spoof data instead of generating new data. So we try to keep it consistent, at least using the same data every time we try to register, or rather log in.
Ideally, it will be the best if we can have some user to actually type in some other user's password. But because of security concerns, we don't feel comfortable doing this. What we might do in the future is we might have ways to break down users' password and then have other users to just type in partial of it and then combine those back together and to construct the data set. But on the other hand, that means we have to save plain password somewhere for us to do research. If it's a public database, we just, as a security.
We felt really uncomfortable saving hash passwords.
What if they're fake passwords like Android students?
Well, and another thing is, in an experiment, you don't care about security, right? I mean, when you implement it, that's important.
When we were gathering the data to run with Dr. Dean, what we actually did was exactly what Tim explained. We created a page where it would randomly show another user's actual password, and another user type it, and we use that to run the analysis. So our current system is not as accurate as that system because we had actual people typing the false user while our system spoofs the false user, if that makes sense.
Yeah, we also discussed the opportunity to take a large corpus of text and have people type through that and then get the timings between characters, 2 grams and n grams of letter strings, and then deducing what the normal population is versus, you know, the true positives.
Yeah. Answer the question.
Yeah. So from what I can see, like the first time it failed for me, at what level would you consider this effective? Like, I mean, how many like tries would you need for this to be effective and for companies to feel comfortable?
It would need, of course, much more extensive testing and a better spoofer of the false user. I wouldn't feel comfortable having organizations implement it unless there is at least an 80% successful rate where it can predict with 80% accuracy the right user or the false user.
Especially the false positives,
Yeah.
where the false user login actually got in, those are the ones we'll be focused on.
We would want to be even.
Well, I think that once you got through that initial learning trial, and then every time the user logged in, you updated, so your sample was really, really large.
Yeah.
You know, you've got a short-term problem that eventually becomes a non-problem.
Mm-hmm.
So I think that would help too. So you should figure out which of those you're trying to solve, or maybe you solve two problems. You solve the first one, and then figure out how quickly it goes away, how infrequently you get false positives or false negatives as they get into a cycle.
And what's really good is the back end, we're using a third party that Tim mentioned is called Accord, and it's statistical third party API. So it has all of this information that we could easily implement into our back end.
Well, I think you have a very interesting project that you've done and made some great progress on it. Thanks. Okay, we have a little break here until 3:30. We'll get us back on the schedule. Joseph's going to be presenting advanced security topics.
Yeah.
Did you do it? Oh. I think if we switch it over to, you know, the pass-through and then
It's supposed to be actually, you just type
10 minutes? That's what I think. So, I don't know if you saw the ISP, just called me. Actually, opposite one. An email from OIT. Yikes.
That's fair.
Good to see you. Good, how are you?
My first piece
I just have a very quick question. I watched the presentations online. Does that count towards the
Yeah, I'd like a culture of being supportive, and I think being here something, but yeah, you're good.
Okay, well, and I might be able to still figure out. I just wanted for in terms of numbers. Okay, thank you. See ya. Good to see you, Dr.
Maybe I should say that because we're here.
But that's really good. So we're almost there. We have some learn generate an object that already is and then you have a certain way to click. So like is it red?
That's still do our business.
Some click on object, we don't know which one to open because there are a few layers. Does that make sense? So like, and that's the way so we can solve it, the problem. Like, we're just kind of, like, we're just going to happen kind of, so that's all, that's just how it
Why are you staying? You don't want to be here.
told you that's one of the washers. So, is it for the,
I think you got a picture of me last night.
Yeah, I know.
Tim was like, smile. I was like, did I hey, look, I smile. Yeah, send it to her. Well, I think I'm gonna piece it because I have a lot of questions.
it's just, yeah, it is something that there's no time to cover.
Yeah, that'd be good.
Yeah, well, it's funny, it's like, you guys consider this, it's like, well, we did that. We just, it's on our final product. You can't, you gotta have to pass where you can't show it. So like, what we did. Yeah.
What's that point?
Oh, good.
I know you can't even about it. I was sure. I was very, sorry, man.
Stuff I'm glad they didn't ask is, look your survey. 3.
What is it? Oh, was it homeless? I was very that one. No.
If they're not, I'm not.
No.
I don't know really well. I felt bad because I look over here and it cares. Good job, man.
Almost.
Almost. Now I just have a pile of papers.
Oh, offers.
Yeah. Most importantly is we did a survey, we built a website. That means we get automatically I think it's A minus. No, we're like, if we finished everything, we get an A. If we finished everything but 1, we get an A minus. If we finished everything but 1.5, we get a B plus.
Our lowest score is we didn't finish anything, but everything was flat and design. And then we get a B.
Yeah, and we get a B.
We're like, really? We didn't at this point. It was an awesome.
This guy, he's in the Mac program. He's like,
As soon as
should I try to talk like him? So like, guys, like, do you have to do projects that are like really hard in time consuming? Because like, us in Mac, we have this like class that like, we have to do stuff, but like, we didn't even do it. It's just like,
the projects with 5 hours on there.
Like, they just, he's like,
We're just not
going to do the problem.
no,
It was Mac.
We're so easy to graduate. We just have to show up. That's it.
Yeah, and I'm like, we have a lot. I mean, I don't know. That's the thing, that was 100.
I know. I think the green version was made up on.
Nice.
Are you?
Well, that's awesome. Thanks, Steve. Well, I'll check
We'll go
on
and
that
check.
later, see if that makes sense.
Yeah, that's right.
So,
So like using this, or the other stations?
Not yet, but if you'd like to.
So,
that's
if you want. Yeah.
Sure.
So what I do is
Very common.